Hello, hi there.
Hi, great to
Hi,
see you,
Dmitry.
Eridian.
Great to have you here today. So, welcome to the Community Staking podcast that I've hosted a number of times now. And today we're speaking to you about the CSM. And you're going to tell us what that acronym means and everything about it as we get into this. But first of all, just like you to introduce yourself to everyone listening to get an idea about who you are and how you're involved.
Okay, yeah, first of all, thank you for having me here. My name is Dmitry, and I'm a technical leader of a group of Lido contributors, currently heavily working on development, research, and all that stuff around CSM. Uh, yeah, so that's why I'm here, and I would like to share any insights, details, and information about our current progress because I do love our product. I think CSM is by far one of the best things that can ever happen with Lido.
Okay, great. So before we get into that, we've chosen to start with now. Just talk about yourself a little bit. So one of the questions I like to ask people on this podcast is, like, when did you get into crypto? And the reason for that is to show that not everyone has to necessarily be a complete OG and say they were in Bitcoin in 2003 or something, but just to be able to say that the people joined at different times and you are never too late, even if it feels like it. So tell us a bit about your journey then and how you got into crypto.
I joined crypto as a developer about 2.5 or 3 years ago, I would say. And I was never been crypto OG for sure. But what helped me with it is that I have PhD in math, and it was wouldn't say pretty easy, but it was comfortable for me to get into crypto. I was super surprised with the amount of information, concepts, approaches, and the velocity new approaches appear. So it took me around a year to get used to it, to dive deeper into the ecosystem. And I'm still mostly Ethereum focused, I would say, because when I try to dig into, for example, Cosmos, I understand that, oh, that's hell ton of new information. That's for now be focused on Ethereum and just try to keep main concepts, the most interesting things out of the other crypto world. So yeah, I'm not that old here, about 3 years, I would say.
Okay, great. And you've covered a little bit there about your background. Again, asking people whether you're more technical or non-technical. The reason for asking that is that there's this assumption that everyone has to be super technical to even be involved in this space. So just to give a bit about your view on it, do you see yourself as more the technical developer or non-technical side?
At the moment, as a technical lead, I am definitely on the technical side. But if we look at my background, there were a lot of things there. So during my PhD, I was working as a teacher for not only for students, but also for school children. I was teaching them math, physics, computer science, and all that stuff. After that, I realized that in my home country, there's no way to earn enough money while doing science because it's really low paid. And I switched into traditional software development. So I was working as a DevOps engineer, as the QA engineer, as the QA automation engineer. And before joining crypto, actually, me and my team, we joined Lido all together as the contributors. And prior Lido, we've been working on an enterprise grade storage systems like Hadoop, Kafka, and all that stuff.
Okay.
Super high loaded things. Yes, and we've been working on actually automatically testing it, and then we switched here. So I would say that I'm definitely a technical person, but my initial head start was, I would say, in science and in university. And then I gradually switched to technical. And now with crypto, I can say that I'm 100% technical.
Okay, that's great to hear the journey as well, to go from slightly less technical and building up that technical focus to where you are today. So yeah, that's really interesting to hear. Okay, so we've talked a bit then about your background and how you got to where you are today. So now we're going to talk about where that is. So as a Lido DAO contributor, you are working on CSM. Now, Can you explain to us what CSM is, what the acronym stands for, and how it fits into the Lido ecosystem?
Okay, let's start from the name. So CSM stands for Community Staking Module. And there's three parts. Let's break them down. First of all, community. It means that this product is, first of all, facing the widest staking community, the widest crypto community ever possible. Second, staking. That's simple. Lido is a liquid staking protocol, community staking. So we are talking about Ethereum staking. Cool. And what module means? Module is a pretty it's a pretty unique feature for Lido because, as you may have heard, in Lido v2, a brand new modular architecture has been introduced, and previously the only I would say entity within the Lido validator set was not operators, were not operators. But starting with Lido v2, there's a new level of abstraction called modules. So first of all, stake comes into Lido smart contracts, and after that, it is not directly distributed to the node operators, but it is distributed to the staking modules. And staking modules, in turn, distributed internally between the node operators. So what it allows for? It allows for creating different modules with different rules to enter this module, to participate in this module, to get rewards. And community staking module is one of the meaningful pieces in this modular architecture, aimed, first of all, to allow community stakers participation. And that's why this module will be permissionless.
Okay, so it's a great introduction and explanation. I think one of the meta models I've used to understand how this modular architecture works in Lido and also get a sense of scale is to imagine it like water in a bathtub. So if Lido is the faucet, the tap, and there is ETH pouring out, it's going somewhere. And in the previous V1 world where it was just Lido, it was just one big bathtub which contained all of the permissioned operators, and that's where all the ETH went and it filled up. And now what's happening is that a second smaller, say, bucket is being added next to that bathtub, and a small amount of the ETH or the water is going into that second smaller bucket, which will be permissionless to join that pool. So
Yeah,
just to get a sense of scale as well, it's not saying the entire Lido bathtub or the entire curated module is changing or disappearing, but it's to say that a percentage, a small amount will be going into this new module. And in that world, you could also imagine that there could be new modules added in future that have various different criteria. And because it is a fixed amount of ETH in the Lido ecosystem, any ETH that comes out of the curated module set and goes into this permissionless set is moving away from permissioned operators to hopefully permissionless operators.
yeah, somehow. But what I want to add here is that in your analogy greatly describes the very, very beginning of CSM. So at the
Yes.
very beginning, CSM indeed will be a small bucket. But if we look at future, we cannot predict the future, but we can aim for something. And in the future, how I personally see Lido with this staking router architecture is not a huge bathtub and several buckets behind, like nearby. I would say that there's several different water storages. It might be bathtub, bucket, huge bucket, something really small. And the shares here will most likely be determined, not eventually be determined, not by the Lido governance itself, but by the market and by the supply and demand. What I mean here is we hear a lot of I heard a lot of like multiple times that, hey, you guys, you are limiting CSM. That's bad. That's the only reason to start CSM as a small bucket to battle test it, to make sure that all this stake is still secure. But once battle tested, I do believe that eventually we will have 3, 4, maybe even 5 modules with limit set to 100% or basically unlimited. And after that, depending on the number of node operators willing to participate in this or that module, for example, in simple DVT, in some DVT modules, in CSM, for sure, in the curated module, the amount of like would say capacity of the curated module will always be higher than the inflow of the stake. That's why curated module will always be not the last one in this priority, but I would say that if we will have, for example, if Lido will have several modules where demand is a function on both stake and node operators, then
Yep.
these modules will be balanced first, and only then stake will go to the curated module. Or maybe we can even end up on par, like with having 5 modules with the more or less even stake distribution. So that's important to keep in mind again that CSM will be a small bucket indeed, but only at the very beginning. And after that, I believe that the share can be increased. But it's very important to keep in mind that for the permissionless modules with the bond, you not only need to say we are allowing any stake to enter, or like any staking protocol saying we are self-limiting at 25%, but currently we are at 2%. I mean, that makes sense, okay. But I don't think that this limit will ever be hit. So with the permissionless modules, the situation is the same. We can say that stake allocation will be 25%, but if there's not enough node operators, this stake will have no place to go, and eventually will go to the other modules.
Exactly. So we'll talk about that a bit more when we talk about things like economic efficiency and how these modules will rebalance and how that works relative to other existing um, solutions that look similar. So, but before we go on to those like more technical details, explaining the economics of it, um, why even build CSM would be a good question to ask. Is that Lido in its current state today has a curated operator set with in quotes like infinite capital efficiency in the sense that it can absorb 10 ETH or 100,000 ETH, and the curated operators can just absorb that. So why even create this module? What's the need for it?
That's pretty simple. From the very beginning, when Lido was eventually created, not eventually, but initially created, uh, the goal and the mission of Lido was to make Ethereum secure, and it is still so, and decentralized. And the decision to start with the curated set was made intentionally, because if you want to build something really reliable, you need to start from the simplest option, and then gradually increase the level of complexity, the level of risk assumptions to achieve this final goal. And CSM is an inevitable step towards Lido helping Ethereum security and decentralization, because with the curated set, it is not feasible to maintain both quality of the curation and the size. So it wouldn't be possible to have, let's say, I don't know, 500 best curated node operators, because it's impossible. First of all, I don't think that such number even exists, and even if it is so, it will be extremely hard to curate such a huge number of operators. While with the permissionless modules, where you don't need this trust and curation, and you can protect user funds with the bond, you can allow anyone to participate, and this drastically increases the possible number of the node operators. So curated was to start with, to make it robust, to make it battle tested, to make it secure. And now when we have this product that is really secure, really robust, really battle tested, Lido contributors can start working on adding these cool features to eventually become not only something that is really secure, but lying somewhere in between centralized and decent and like fully permissionless decentralized solutions.
Yeah.
But to transfer to a hybrid model where you have curated part, where you have permissionless part, and you combine all the benefits of them together. But with no doubts, permissionless part is way more risky and way less scalable. So that's why initially it was a curated module, and now we are moving towards permissionless because it adds a lot of benefits. It adds new node operators, security, decentralization, and having this solid base that we have now in the form of a curated module, we can proceed further. By we, for sure, I like to associate myself with the product, so I might say we when I speak about CSM, when I speak about Lido, but for sure Lido is down. We all know it.
Yeah, DAO contributors. So yeah, and I think that's a good way to describe it. The thing about scale, you mentioned what scales more easily. That's quite a loaded term because it can mean different things to different people. It's whether you mean like scaling the human element of the curated module. That I'm aware of how much effort it takes to manage the curated module because there's no bond. So while that's great that's actually like infinitely scalable from a technical perspective, from like they can absorb those operators can absorb huge amounts of ETH. The coordination side around that to actually have no bond, but then trust them, and then the size around that scale has different issues. So we'll talk about that a bit when we come on to like specifically around the bond, and we can move on to that now, particularly talking around the bond because that's the main difference with CSM versus the curated module because that's the key that unlocks the door in the curated module, the current set. When there are onboarding rounds, people apply, and the way to get through the gate to get in is to be accepted through interview processes and various KYC and things like that and technical
I
experience.
would
So
I I would not say directly KYC, but yes, some
they
for
have to
some
be somewhere known, as in they're not fully anon. They have to be somehow known.
exactly.
So which is important because that's what curated in this sense means. So the unlock for CSM and the permissionless module is that therefore there has to be something else, and that's something else to get through that gate is the bond. So let's talk about that now before we move on a bit and talk about like relative bonds and the implications of it. Just talk about how it works and why it's needed to start with.
The idea is super simple. So we all know how Ethereum validation works. If we don't, then you need 32 ETH to be placed as a stake, and it allows you to create one validator. And with this one validator, if you operate well, you get rewards. If you misbehave or, for example, you get slashed, some part of your initial bond is getting burned. I mean, the original Ethereum stake or bond, name it, whatever you like. But the thing is that this 32 ETH is, I would say, it's super, super, super over collateralization. Why? Because in the majority of the possible cases, in absolute majority of the possible cases, only small part of this 32 ETH is actually subject to penalties or slashing penalties or any other penalties. Theoretically, it is possible that in some cases, all of this 32 ETH might get burned, but it has never happened anywhere, not in the testnets, not anywhere. And it should be a total disaster. So that's why one can assume that sorry, my laptop is switching the screen off. One can assume that if in the majority of the real world scenarios, not all of these 32 ETH are actually required as insurance, this 32 ETH might be split into two parts. So the first part that we call bond, it is provided by the node operator, by a person or entity or I don't know, who operate the actual validator, who is responsible for correct operation, for not committing double signatures so that it wouldn't get slashed, who commits to be online and so on. And the rest is provided by the stakers. So we cannot say that this part provided by the stakers is risk-free, but we can say that this part is risk minimized, while bond provided by the node operator is more risky for sure. So all the penalties will first be applied to this bond or all feasible penalties that might be accounted for. But since this funds, they are provided by the node operator, by the person who is actually running a validator, who is responsible for it. He has a huge control So if he operates well, if he maintains security principles and so on and so forth, there will be no penalties. So hence, he can manage his risk profile depending on how he actually operates the validator. While stakers cannot, that's why they have this reduced portion. So bond is just a part of 32 ETH provided by the node operator that is firstly subject to a penalties first before the user stake.
Yeah, I think maybe an analogy could be something like a car rental. So if I wanted to go and rent a car, the car itself could be worth, say, like $30,000. But then I would put a deposit down to be able to rent it and go and drive that car. So I put, say, $500 down. Now, that $500 should, in most cases, cover any small amounts of damage or any small issues that are very likely to happen. But the chance of damage being significantly more than that is very rare. And therefore,
Yes,
you can have this bond where it covers most cases, and it's all about risk profiles to understand like how likely are you to write off the car completely and cause $30,000 worth of damage, like relatively low. So that's where the bond could be a reasonable analogy for people to understand the bond and why it's relative to the maximum amount of ETH.
yeah, for those like me who are now listening might argue that in car rental, there's also insurance involved. So let's imagine that we've simplified this particular example and there is no insurance involved. So the only insurance is the deposit that
Yes.
you've provided. And in this case, it's like 100% match.
Yeah, but that would be the car rental company's problem to deal with, like their risk management. So similarly, Lido will also have a risk management strategy, not necessarily insurance in the same capacity, but understanding like the bond amount to therefore offset the risk potential and things like that. So
And not only that, on top of the bonds provided, there's still this thing called Lido Insurance Fund, and there's approximately 7,000 STEF here at the moment. And these funds might be used by the DAO as the insurance for, I would say, any slashing cases. So for the stakers, community staking module is something super cool because you have two layers of insurance. The first one is the actual bond provided by the node operator, and the second one is this extra layer provided by Lido.
okay, so let's talk about the bonds a bit more then in terms of the economics. We've explained why the bond is needed and how it unlocks the gate for permissionless operators. But this isn't a new concept. We're not describing something that hasn't been done before. This has been done before with, say, like Rocket Pool. Rocket Pool was the original concept, was a 16 ETH bond on the one side, and then 16 ETH provided by the community or the pool. And that's how it came together. As you've just described, that bond is relatively high, given the max potential risk or the most likely potential risk. So
Most likely, yeah.
recently, Rocket Pool has lowered that to 8 ETH bond and is looking for reductions. So, but the idea of a bond to allow permissionless has been done before. So talking about the specifics of CSM, so we've got the absolute bond amount and what the goal is there. The starting point, the considerations to decide on like what that number should be to start with, given as I just said, for example, Rocket Pool started with 16, then moved to 8. What are the considerations, if not the actual number that's going to be used? And then talking about like what implications that bond has for things like scaling the module and balancing with the curated module. So just start with talk about the bond specifically and how those calculations being done and how's that going to be decided?
Okay. So if we talk about the actual calculations, the best person to talk here, and you already talked with him, is Max. And you can follow some links that we will put in the description to the video, to the research forum where all these calculations are made. But the gist is the following. Let's start with the Rocket Pool and why they initially started with 16E. It was back in the day where Ethereum was not a thing that it is at the moment. A lot of updates went live since that time. And what I think I can assume, I don't know for sure, but I can assume that they initially started with 16 ETH because of the fact that initially within a beacon chain, there is a rule that if the validator's balance goes below 16 ETH, it gets automatically ejected. And except for catastrophic scenario of huge correlated slashing. In all other cases, one can assume that validator balance will never go below 16 ETH. And that means that any loss like not higher than 16 ETH will be covered by the bond. I think that's why they started with it. It's a super conservative approach, and we've talked with the development team multiple times. They are great guys, by the way. And yes, they told us that they tend to be as conservative as possible to maintain security, and that's fair.
That's great. Yeah.
But since that time, a lot of things has changed. That's why Rocket Pool moved to 8 ETH. Why they did so? Because they re-estimated the risk model based on the real world data, based on the things available. And now, when we know that most likely in Electra, there will be execution layer triggerable exits available, we can re-estimate this risk profile once again. What we need to take into account? We need to take into account basically two things. It's the CL penalties or consensus layer penalties. It is either penalties for being offline or for misbehaving or slashing. That's the first thing. And the second thing is EL rewards or execution layer rewards, also known as MEV in some part, stealing. So what can malicious node operator do? He can either never turn on the validator, he can intentionally slash the validator, or he can steal MEV or steal EL rewards, because there's no way for the protocol to force a node operator to do so. It's only up to him what he will set in his local configuration, his local MEV boost and node configuration. So if we assume that we have a community staking module filled with only malicious operators, no more no less, only malicious, and they all try to act as maliciously as possible, we need to be sure that the bond amount that has been initially requested from them will be sufficient to cover maybe not all, but the absolute majority of the cases. And with the triggerable exits in place, we can, our protocol can detect and trigger exits, for example, for offline validators. It can also, so it reduces this time span. So there's no chance that validator will be offline for a year and will never be ejected.
Yeah.
We need also take into account the fact of slashing. And if at the current size of the network, again, when Rocket Pool started, network was really small. Now it's tremendously large. And with the current size of the network, for the midterm penalty or for the correlation penalty to flip from 0 to 1 ETH, you need to have simultaneous slashing of 1,000 validators, 10,000 validators. Yes. And I don't think that it is even a possible case. But what we need to assume is we need to imagine the situation when, for example, all CSM validators are getting slashed. And based on that, we can assume that with this small allocation, at least for the very beginning, there is no chance that this correlated slashing can be triggered only by CSM validators, which is great. That's why we can assume that slashing penalty will be minimum possible. So 1 ETH initial slashing penalty or minimal slashing penalty plus some penalties for being off for missed attestations. So it will be 1 plus something ETH. Okay, and the last but not the least is MEV stealing. And here the situation is, this is the place where math goes a bit aside. Why? Because if we calculate in absolute numbers, we can say, okay, what was the highest MEV? And we will see that it was, I don't know, like 1,000 ETH per block. Maybe. I guess the number,
it's between 500 and 1,000. It is,
yes,
yeah.
yes. So somewhere there. And in this case, we can confidently say that there's no way to cover it by any bond. Like, bye-bye, we wouldn't do anything. But then we use statistics. We are saying, okay, and what is the median value? What is the mean value? How can we assume it? How can we detect it? And so on and so forth. And based on this data, we can come up to some conclusions, but these conclusions cannot be, I mean, these conclusions will be different depending on who is looking at the calculations. So the best way here again to research to refer to the research forum to read the posts that we have. I think there will be updates on the risk assessment and the bond size calculations, maybe in spring or in summer, but definitely before the launch of CSM on the mainnet, these values will be reconsidered. At the moment, we can say that before Dencun and with no triggerable exits for ETH as a bond seemed to be a reasonable value to start with. But since we now know for sure that, or not for sure, but almost for sure that triggerable exits will be included in Electra, it means that the risk assessment profile should be recalculated. So stay tuned for the updates here.
Okay, great. Yeah, I think 7002 is incredibly useful for LST protocols to actually have some control over the validators. Now that does I've talked about this on the podcast before, like shifting the governance risk. It makes a change, like that's a change to Ethereum, which helps in the current conversation we're having. It also does have some knock-on effects. For example, right now, if Lido or the DAO became malicious in whichever way that's defined to either Ethereum or to the holders, currently they could ask all the validators to exit or to steal MEV or do something, and all the operators could just say no right now. So there's this like soft power, hard power gap, which is changed by having withdrawable address triggerable exit. So not something for this conversation, but just something to consider is like there are these knock-on effects, like while it's positive or has some seems like only positive benefits in some areas, there can be other areas where it does change, as you said, risk calculations or governance profiles and things like that. So that's also being considered in other areas with like dual governance, but just something for people to look into if they're interested.
Yeah, and one important thing, at least according to the internal conversations between contributors, the plan is to first of all propose dual governance as the update, and only after that propose CSM. So I can assume that CSM will most likely be released after dual governance, and it means that once CSM is released, this governance risk will be drastically reduced. I would say it will be mitigated because of the fact that STE holders will now be involved and the whole ecosystem will be, I would say, consistent right now. So now it is not that consistent. One may argue that there's LDO holders and STE holders. But with dual governance, all of them will be combined in some form. But if you want to learn more, yeah, definitely go read research forum. There's tons of discussions, really interesting discussions, I would say. But for CSM, what is important to know is that dual governance will be released before CSM. So for CSM node operators, this risk will be mitigated. And yeah, that's a really important thing to note.
Okay, cool. So then one of the things we just touched on was MEV stealing, and I want to talk about that a bit more because some of the, as you said, the internal contributor conversations that I've been having have been very interesting around that, because while we've talked a lot about the mathematics and like risk profiles and things like that so far, there are some human elements to it that come into play. So with MEV stealing, and we've used the word stealing, but what we mean by that is that when you have a validator and an operator and you're running your validator, you choose where to set the MEV rewards. You point the MEV rewards to a fee recipient address, and that's set locally. So while the withdrawal address for the full 32 ETH is set on like the protocol level, so that's set to the Lido withdrawal address, fee recipient address is set by the operator and can be changed. Now, when we talk about stealing, that's this idea of like some coordinated or malicious plan where they set it to their own address and hope for a lottery block and then steal it. And that's why something like 7002 would be fairly straightforward, because you'd say, okay, this person set the wrong address and they therefore must be stealing, so we're going to kick them out. But in reality, what's much more likely to happen on an individual's basis is that they'll configure their node, they'll set it up wrong, and then they'll set their withdrawal address either to the zero address or something like that, or to their own address by accident because they're confused. Now, that doesn't necessarily mean it's evil malicious, but it is not working in the best interest of the protocol. So one of the conversations that was in a call, I think it was last week, was saying there's this idea of a delay or like you have if you steal the MEV or you go to the wrong place, you have a few days or a fixed amount of time to give it back. And while
Yes.
this might not be like implemented, day one, but just the idea of the conversation that was had around that, if you realize like, oh no, I proposed a block and I sent the withdrawal address to the fee recipient to the wrong place, you could give it back and it would then allow you to kind of keep in the good grace of the protocol and not have any negative social reputation against that, let alone the economic side. So I thought that was really interesting, just a conversation that was being had.
That was not just a conversation. Actually, we are currently working on a detailed document regarding CSM architecture, and one of the features is, yes, related to the MEV stealing. Since there is no way to actually detect all the cases of so-called MEV stealing, or to do it in a permissionless way or something like that, there might be tons of situations. What we will propose for CSM is to have this two-phase system. So first of all, there's a dedicated actor. It might be some committee or automated tool or whatever that can report that this validator seems to be stealing MEV, and the amount that is assumed to be stolen will be locked on the bond, but not burned. That's important. And then for a while, I would say at least for a week or so, node operator will be able to either communicate with the DAO, for example, go to the research forum and say, hey guys, that was my fault, take a look, that's a zero address, I'm so sorry, like that, maybe. Or if he actually used, for example, his own address, he's a proven solo staker, he configure validators like 10 times a year, and for CSM, he just used the same configuration, and he see that, oh my God, MEV got into my address. He can
Yep.
simply use a specific method within CSM to compensate for it. And if the amount compensated is equal to the amount actually locked as a penalty, uh, then okay, we're good to go. No more thing, like nothing to be penalized for. Everything was
Yeah.
compensated. That's great. And another thing that I want to add about MEV stealing that you've mentioned and that we've discussed with you maybe half a year ago, I don't know, that unlike consensus layer penalties, MEV stealing is not a direct loss for the protocol. So I would say it's a missed profit or not a proper directed profit, but it's not a direct
Yeah.
loss
We
because
said this. Well, we had some
yeah,
complicated conversation around like, how is it different to a missed block? So if I steal the MEV and I actually set the fee recipient, but what if I know that the next operator, for example, if I ran a CSM validator and I also ran a validator from home, then what you could do is maliciously miss the block from the CSM validator and then take the MEV in your block. Now that wouldn't be as attributable because it would be more complicated, but as a concept, how is missing a block different to stealing?
yeah. So there's definitely a difference between a missed block and MEV stealing, because with MEV stealing, there might be a malicious intent or mistake. For the mistake, we have the specific method and specific time frame to compensate for it. But if it was a malicious intent indeed, then in this case, for sure, there should be some penalties for the node operator or measures, maybe even ejection or something like that. But from the protocol security perspective, what I would say, if we move back a bit to the bond, in a lot of researches about the bond that I've seen, this amount of possible MEV stealing is assumed that it should be fully covered by the bond. But actually, I think there might be a different point of view here because of the fact, again, that it's a missed profit. And what is more important, this profit is totally unpredictable. So the block might be missed. There might be no MEV for a while, or there might be no MEV for this particular block, but there might be huge MEV for the second block, for the next block. And you can never it's hard to estimate like was it a matter of chance or was it a bad luck or good luck. So I think that when considering the possible amount of MEV stolen, we need to take it into account for sure, but we need to be less conservative than with the CL penalties. And one of the things in CSM that will also facilitate this fact of MEV possibly being huge is a common bond for the node operator. So if you create 1, 2, 3, like 5 validators, for example, bond will not be associated with this, or that validator. It will be associated with all of them. And if any of these validators commits MEV stealing, all the bond will be subject to potential penalties. So it drastically changes the risk profile here. Yeah,
It does, yeah, and
that
particularly with that final point you just made around, well, then why would you want a shared bond if it was therefore all at risk from a single validator? The case there would be for non-linear bonds, because you'd be
yeah,
incentivized to have a non-linear bond. So the first bond might be 4 ETH, and just in simple terms, the next bond will be 3 ETH and 2 ETH and 1 ETH. So you would be able to have more validators. It won't work quite like that, but that's just the idea, is that each validator would be slightly less, and there may be a plateau point where that becomes the minimum bond. And then shared bond, that those two would work really nicely together, because you would be incentivized to pool your validators to be under one account or org or address in that case. And then that would also help with MEV stealing for people that have a large number of correlated validators.
yeah. And taking into account recent research by Rocket Pool that I really like, I would say, in their nonlinear bonding model, they assume something very stiff. So you start with, let's say, 8 ETH, and then for the next validators, you need 1.5 ETH. While it makes total sense from the security perspective, I admit that it is so. However, from the I would say entry barrier perspective, it most likely incentivizes not as small operators but huge operators, because with this difference, 8 ETH for the first validator, 1.5 for the second. Again, maybe it was just an example, but I really saw something like this. So in this case, for me, it's more of an incentive for huge operators rather than for small operators. So for CSM, when designing this curve, while doing these calculations, again, they all will be posted. I would say that we are mostly focusing on allowing for the minimum possible entry bond, and then reducing it, but reducing it not drastically. So not to reduce it, let's say, from 4 ETH to 1 ETH. I would say that it is not even possible to reduce to 1 ETH because of the fact that minimal slashing penalty is still higher than 1 ETH. So I would say that if I was asked at the moment, like, set this bond curve immediately for your imaginary CSM, I would say that it should start from something like 4 or between 4 and 2, depending on the recalculated risk assessment, and then gradually move down to something like 1.5, maybe 1.2, but no less than that. And what is important, again, that this difference, it should not be substantial, because otherwise it will be a direct incentive for a huge operator. So for example, I don't know, for any professional, he can say, okay, we can afford this starting 8 ETH, no problem. And after that, we will have the super discounted validators. Let's create 1,000 of them on top. Why not? And that's not the most desirable case for CSM. I wouldn't say that it is not desirable. I mean, it's permissionless module, anyone can join. But what is more desirable for CSM is to have net new node operators, and not only for Lido, but for Ethereum in general. And to do so, this initial barrier should be reduced. And there are some ways to reduce it, and we are working hard to implement all of them, not to
Yeah.
compromise on security.
And I can see that. So as a solo staker at home, if I was looking at the CSM module to join, which is what we'll talk about to close in a second, I'd look at it and I'd be like, oh, wow, if I had 8 ETH and then the next one is worth only 1 ETH, that's great if you have 9 ETH, but if you don't, then that's no good. But if I had 5 ETH and that was the bond, then it was then 555, I'd still be better off that it was 5 rather than 8, just because the barrier to entry is lower. And as you said, if net new is the case and lots of single operators, or like pooling together with friends, actually increasing that decentralization, then lowering that initial barrier is more important than having a high first barrier and then low second hurdle. So yeah, I can see that definitely. And things like DVT and being able to have pooled operators with CSM. So even though we're not going to touch on this right now, we should save it for another episode, I think. But talking about other modules and how they fit together, the cool thing about CSM is that it's it doesn't preclude or stop being used for anything else. So if you have a CSM validator, once you have it and you have the validator keys, you can then go and do whatever you want with it. And by that, I mean you could go split it using SSV or OBOL, and you could split those keys and then go and run it elsewhere. You can use different DBT protocols like that, and there are lots of things you can do once you have it. Which means that it's very incredibly flexible. So that's why getting CSM right is powerful, because it will allow people to experiment. And if then in future they say, oh, this would be a great module on its own, then it would be a great way for the people to test out module designs behind CSM essentially to get started. So as we close out now, so thank you for all that amazing information. And as you said, we'll share some links in the description of this video and on Twitter when we share this. Is there anything you'd like to say to someone that's watched this or got this far through and they're like, well, how can I get involved? Like, if I can't join tomorrow, how can they get involved today?
Okay, so the best opportunity by far at the moment, so today is 21st of February. That's the day when we are recording. And at this moment, the best opportunity for community stakers to join is Simple DBT Testnet. With Simple DBT Testnet, basically the only thing you need to do is you need to have minimal experience to start with DBT, either OBOL or SSV. So at least for a month, you can come with your friends, or probably you're already running the testnet validator with your friends. And that's the only requirement. After that, you can apply for, or you can apply even earlier for Simple DBT Testnet. And this is a straight pathway towards Lido testnet and maybe even Lido mainnet. And what is important here, no bond required, because this module is curated. It's a playground. I would say it's a mainnet playground for DBT, real full-featured big playground. So no bond required, unfortunately curated. After that, I believe that the next step for those who want to be involved will be CSM testnet. And I really want to see it live on a testnet somewhere in the middle or maybe late summer this year. We will do our best to do so. And within 3 or 4 months after testnet, there will be CSM mainnet. So for now, go fill in the form for Simple DBT. That's the best opportunity now. Stay tuned for the updates regarding CSM and make sure to join CSM testnet. And then CSM mainnet, and here we go. Validation with Lido.
That's it. All right. Well, thank you so much for sharing all that information and for explaining from basics what CSM is. I hope that we can have a few more of these podcasts where we go into detail on specific areas and talk about like the actual more technical module design and some of the decisions, and even actually do a podcast where we walk through the RFCs and the various blog posts so you can describe them in person to people and we can ask questions and talk through that way. So just giving people different ways to absorb the information, as we talked about before the recording started. The idea, the fact that the proposal is massive, the original content that you've written is huge. So breaking that down either through smaller posts or just talking through the key concepts on a podcast like this would be great. So I hope that we can do that again in future.
Yeah, I would love to participate, and I would also love to see guys from the team talking with you on the specific concepts, because one internal insight, we are not working all together on everything. We have guys specializing on this or that topic, so it will be a great opportunity for the audience and for you, Eridian, to speak with the particular technical guys, because, for example, one of them is working on a performance oracle. The others are working on a bonding curve, and they have tons of insights to share about it, and they are really passionate about what they are doing. I really like contributing to Lido with all these amazing people.
Absolutely. Well, look forward to that future with more community stakers participating permissionlessly for Lido. So thank you very much, and we'll catch up soon. All right. Thanks, Dmitry.
Thank you. See you.
Thanks.
Bye.
Bye.